flow classification ke, what is the definitions of hydrodynamics, what concept we use in this topic. Ada yang nak share? Razi ada? Razi? Oh, Anisha. Anisha ada. Anisha Iliana.
Ada, madam.
So, boleh cerita sikit apa you learn from the video?
Saya tak berapa nak faham.
Which one?
But yang flow visualization tu.
Flow? Mana flow apa semula? Visualization ni? Okay, let's see a little bit on this. So, basically, you will learn 3.1.1 until 3.1.5 for this week 8. So, you have the introductions, basically the definition and also the concept of fluid flow, flow classification, the relationship between velocity and also discharge, and lastly, the conservations of mass and the continuity equation. Okay, so previously you belajar tentang fluid yang tidak bergerak. So for this topic, the fluid start moving. So bila dia start moving, there is a fluid flow. So bila dah ada movement, means ada velocity, ada shear stress, and it involve the flow rate. Flow rate ataupun kita panggil discharge. Apa yang kita boleh tahu daripada discharge ni, kita boleh tahu berapa kelajuan fluid tu bergerak dan juga fluid tu bergerak ke arah mana. Okay, that is on the velocity and discharge. Okay, a little bit on the learning outcome of this topic. What you should understand or learn from this topic. You must be able to explain the concept of fluid flow, the average velocity and also the flow rate. Okay, flow rate is Q. And also you must be able to categorize and differentiate between the steady and unsteady flow, uniform and non-uniform flow, and also laminar as well as turbulent. Okay, for category steady, unsteady, uniform and non-uniform, we don't need to calculate, but to determine laminar and turbulent, we need to calculate the Reynolds number. Okay, based on the Reynolds number, you can determine either the flow regime, it is laminar ataupun turbulent. Kalau dalam bahasa yang mudah difaham, laminar ni adalah ombak yang steady. Okay, turbulent ni bila ombak besar. Okay, they have the very complicated flow of water. Okay, laminar ni dia tenang, steady, wavelength dia sama, velocity sama. Okay, and then you need to be able to discuss regarding the principle of mass conservation, and of course solving problems related to the mass conservation. Okay, so the introductions, you can go through again the video. This is on the definitions. So tadi kawan awak tak faham on the flow visualizations. This one is the visual examinations of flow field features. Maksudnya tadi saya cakap bila laminar dengan turbulent, You can also determine using which is the Reynolds number. Okay, so instead of that, it also can be represented by the flow visualizations. Okay, it can be determined by the picture lah. Tu maksud dia flow visualizations. So you can see here, bila dia punya wavelength sama, the flow is steady, that means this is a lamina. Okay, so this is on quality. You can see the visualizations pictures. And they also can learn by quantitative study. So you need calculations on that. Okay, so basically this one je lah yang you kena faham on this. Visualization is you can see from the flow ni sama ada dia nampak lamina ataupun looks like turbulent. Okay, so you have, you can go through again this one. What is the difference between path line, straight line, streamline, and also the stream tube. Or later if you have time, saya tunjuk video on this one. Okay, and then this one you also can go through. The flow also can be represented into a velocity profile. So one dimensional, you have one directions of the flow. If two dimensionals means that there is two direction of the, there is change of directions. Okay, first dia macam ni and then dia punya wavelength pun berbeza. So it involves the change of flow that cause the two-dimensional flow. Okay, so samalah kalau three dimensionals means there is three different directions. Okay, two directions or three directions. Okay, so I think you already go through this one. This one pun dah explain on the video. Basically kita describe on the what is the difference lah. Apa yang remain constant on the ataupun what is being changed. So you can see the word change or the remain constant. Okay, untuk this one basically they will ask you on the definition saja. Okay, this is part that you need to calculate where we need to differentiate between turbulent and also laminar flow. So dia punya characteristics, you can make your own sentence lah. So the keywords for turbulence is random and also irregular. Okay, irregular ni dia punya space of the flow, arah, it also can be irregular. Okay, lamina is orderly movement. Maksudnya bila dia flow tu dia punya wavelength sama, size, velocity also is the same. Okay, and then it can be defined path and flow tend to move in layer. Okay, so sebelum ni you belajar kan, bila ada boundary, dia akan follow the velocity of the boundary. So the velocity of the boundary ni 0. Semakin jauh daripada boundary, semakin tinggi flow. Semakin tinggi dia punya velocity. Okay, so we calculate this one using the Reynolds number. So you can see here kat sini ada transition kan. So in question, we're not considering a transition. Kita hanya boleh choose the lamina and also turbulence saja. But you should know that there is a transition lah. Sebelum kita pergi ke, sebelum ombak ataupun flow tu menjadi kuat, dia ada sisi transitions of the flow. Okay, and this Reynolds number is unitless, dimensional, tak ada units. So bila kita boleh detect lah bila Reynolds number kecil, which is less than 2000, it means it is lamina. Bila tinggi, it is considered as turbulent flow. Okay, basically on this question, dia tak akan tanya directly what is the Renault number, ataupun dia tak akan bagi simply question you calculate the Renault number. Dia akan bagi different calculation dulu. Contoh, dia ceritalah the flow of fluid daripada one pipe to another pipe. Contoh dia cakap pipe tu daripada kecil menjadi besar ke, atau split into 3 pipes. Okay, you kena calculate dulu the flow rate, dia punya velocity. Last kali baru dia akan tanya what is the flow regime. Okay, so markah untuk ini dalam 2 atau 3 markah saja to find the flow regime. So soalan dia boleh tanya what is the type of fluid flow. Okay, what is the flow regime of this fluid? So untuk yang ni jawapan dia adalah sama ada turbulence or laminar, you kena guna formula Renault number. Okay, let's see the details of this Renault number. So kita ada density ni density of the fluid. Then we need to use the average velocity. D is the diameter of the pipe in meter. And then we also have the absolute viscosity. This one referring to absolute viscosity of that fluid. So kalau fluid the water, the absolute viscosity of the water. Okay, let's go through a question. So dia bagi the diameter of the pipe 20 mm. Need to change to meter. So it is 20 times 10 negative 2. Milli is negative 2. Okay, and then the average velocity of the water flow ialah 1.5. Ini direct question je because they ask you to calculate the Renault number. Okay, just substitute the value into the formula and you get the Renault number is 30,000. So we need to make the conclusion. Since it is higher than 2,300, it is turbulent. Okay, this one has the mark lah. 1, 2. Okay, so untuk Renault number ni ada soalan tak? Dengar ke suara saya ni?
Dengar doktor.
Okay, so kalau tak ada soalan, saya move kepada next point, which is next subtopic 3.1.4. It is regarding apa dia punya correlation between velocity and discharge. Apa dia punya connection? Okay, velocity is in a unit meter per second. So this one saya dah mention, it is a parameter used to tell us how fast and in what direction the fluid will flow. And then discharge is a flow rate. Okay, flow rate ni unit dia meter cube per second. So based on the unit here, you can know what is the formula to determine the discharge. Anyone? Kalau you nampak formula meter cube per second ni, apa formula discharge ni? From the formula tu. Boleh, try. Yes, very good. Volume over time. Okay, so it is volume over time. Okay, so if you can see from the definition here is the total quantity of fluid flowing in a unit time past any particular cross section of a stream. Okay, if you can see here cross section sih maksudnya involving area. Okay, so kita nak derive this formula also can be calculated using the area. Okay, how we determine this one? Maksudnya kat sini kalau pipe lah, contoh pipe. You rasa pipe kecil ke pipe besar tinggi velocity? What do you think? Tak apa, nanti kita go through that one. So how we derive the formula also can be calculated in a particular cross section of a stream, which is area. So volume ni ialah area times length. Betul length kan? Meter. Length. L. Dividing by time. So length over time ni is velocity. Betul kan? Length meter per second. So meter per second ialah velocity. So that's why another formula for Q is area times velocity. Okay, so in this question regarding the velocity and discharge, you having two formula to find the Q, which is volume over time. Or if you don't have time, we use area times velocity. Okay, area times velocity. Okay, so this one is another part of a flow rate ni. So the main flow rate that will be calculated is called volumetric flow rate, Q. So kalau soalan tu tak sebut pun volumetric, but it's only flow rate, maksudnya dia suruh calculate volumetric flow rate. Okay, unless question ask you to find the mass ataupun weight flow rate, baru dia consider sebagai flow rate yang lain. Okay, kalau tak ada perkataan mass dengan weight ni, maksudnya it is referring to volumetric flow rate. Okay, so how we determine the mass flow rate? The volumetric flow rate darab dengan density. It is mass flow rate. Okay, kalau weight flow rate dia darab dengan specific weight. Rho darab G adalah specific weight darab dengan Q. So you get the weight flow rate. Okay, one of the examples, the fluid here is benzene. So it means that inside the pipe we have the benzene and the size of the pipe ialah 100 mm diameter. So the velocity of the benzene flow ialah 3 meter per second. So this question asks you to find the three type of flow rate tadi. Volumetric, Q, weight flow rate, W, and also the mass flow rate, M. Okay, given that the density of the benzene is 879. Okay, so area here is referring to cross-section area. So cross-sections area of the pipe. Cross-section ni maksudnya bila kita potong lah, bila kita cut the pipe from the one point ni, you akan nampak in a circle shape. So we use the formula of circles, pi d squared over 4. Okay, and then just substitute into the formula, you get the flow rate, weight flow rate and also mass flow rate. So ni senang je lah. Okay, so this one is regarding the average velocity. Ni dia derive related to area dengan Q. So finally kita dapatlah V average is equals to Q bahagi dengan area. Okay, this part is just want to explain on the velocity ni. That's why we use the average velocity because we consider that is a small elemental area of the flow. Okay. So we move to the concept of fluid flow. We are using conservation law applied to control volume. So we have conservations of mass. Okay, maksud conservations of mass ni, if you know the words conservation is referring to balance. Okay, maksudnya what entering is sama dengan yang keluar. Apa yang masuk sama dengan yang keluar. Okay, so here mass in sama dengan mass out. Okay, and then it also involve conservations of momentum. Bila awak dengar word momentum, so bila you belajar sebelum ni kita ada impulse, momentum, so dia related to movement yang melibatkan collisions, pelanggaran. Okay, so momentum pun sama, momentum in sama dengan momentum out. Okay, contohnya nozzle of pipe yang keluarkan air tu, you sembur dekat dinding, wall. So maksudnya the water flow hit the wall. So you need to calculate momentum out of the pipe, out of the nozzle, momentum in. So momentum out dia adalah dekat dinding. So samalah. Momentum in akan sama dengan momentum out. So the difference maybe the velocity ataupun area. Ataupun pressure. Okay, so the momentum is still the same. Okay, and then we also have conservations of energy. Energy ni macam, if you still remember, energy tidak boleh dihasilkan dan tidak boleh dihapuskan. Dia hanya boleh ditukar kepada different types of energy. Okay, for example, sebelum ni you belajar on the energy yang melibatkan lampu contoh. Lampu dia menggunakan elektrik ataupun bateri. So it involve chemical energy from the battery. Okay, lepas tu energy tu bertukar kepada light energy. And then bila kita dah guna lama lampu, the light energy akan transform to heat energy. Okay, but the energy itself dia tak akan berkurang ataupun berubah. Dia hanya boleh ditukar kepada energy yang lain. Nah, tu maksudnya conservation of energy. So, energy related to pressure. So, pressure in is equals to pressure out. Okay, mass ni saya tukar sikit sebab dia mass ni sebenarnya related to flow rate tadi. Q. Okay, so it is Q in is equals to Q out. So here momentum in equals to momentum out. So any conserved quantity, either mass, discharge, momentum, energy, must be always balanced. Okay, so kat sini dia dah explain again. Mass in is equals to mass out. Okay, let's see based on this stream tube. So you have the stream tube that move from point 1 to point 2. And then we have the conservation of mass on the steady flow of fluid. So you can see here they have their own area. So we have area 1, change of area 1, and then for point 2 kita ada their own area 2. So mungkin you boleh tengok daripada gambar ni, area dia semakin besar. Area of the pipe ni. Okay, kemudian kita ada velocity U1 or U2 Ataupun you can classify as in velocity in ataupun initial velocity as U or final velocity as V. Either one lah. Guna V ke U ke sama, is referring to velocity. Okay, and then we also have density. So density here basically the same. Dalam satu pipe tu biasanya kita akan ada same fluid. Tak mungkin lah tiba-tiba nak berubah kat tengah kan. So the density here is actually you can cancel because of course we have the same fluid inside one pipe. So mass entering per unit time, which is Q, is equals to U2. Okay, so dapatlah continuity equation as Q in equals to Q out, where the density can be cancelled. Okay, why we cancel the density? Selain daripada density dia sama, we consider the fluid is incompressible. So density dia sama. Okay, maksudnya along the pipe tu, tiada berlaku incompressible of the fluid. So bila tak ada change of the fluid tu, jadi density dia sama. Okay. Incompressible ni boleh berlaku bila kita ada pressure ataupun we heat the fluid. So in this condition tak ada berlaku change of compressibility. Okay, so this is another condition when the pipe is splitting into two. So the concept of continuity equation is still the same. Q in equals to Q out. So you need to determine which one is Q in and Q out. So Q1 is Q in. So we have two outsource, two pipe, two junction for out. So Q2 and Q3 ialah out point. Okay, and then we need to make a equation based on the pipeline ni. So we have Q1 equals to Q2 plus Q3. Okay. So kita nak fahamkan lah. Q1 ialah Q in, Q out ada dua, which is Q2 plus Q3. Okay, and then it consider incompressible juga. So tak ada density. So the formula only involve area and velocity. So we have area 1 V1 equals to area 2 V2 plus area 3 V3. Okay, so soalan boleh tanya which part lah. Contoh dia tanya what is the velocity at point 2. Maybe dia tak bagi nilai kat sini, so you kena cari. Okay, what is the discharge? So you need to find the Q. Okay, so macam ni lah. So when you see this question, you need to make an equation based on the pipeline. Okay, let's see one of the example with the value number. So you have the constriction pipe. Maksudnya pipe ni mengecil. Ataupun you have enlargement pipe. So soalan ni adalah constriction pipe. So the pipe decreased from 15 mm to 3 mm. Okay, so maksudnya kat sini pipe, another part, point 2 is the nozzle. So nozzle biasanya kecil lah daripada pipe. Okay, so you need to find the velocity at the nozzle. So V2 ni tak tahu. just use the formula, write down the equation. Q1 equals to Q2, A1 V1 equals to A2 V2. Okay, dekat point ini, you dah boleh calculate because you have all the information kat sini. V dah ada, velocity. D is you need to find the area. Area of the circle, cross-section area is pi. D, convert into meter, 0.15. Okay, pi d squared over 4. V1 is 0.6. Masukkan je nilai yang you tahu. Okay, so from here, area for 2 dah boleh juga tahu, which is pi, D adalah 0.03 pada meter bahagi dengan 4. So we have the unknown V2. Okay, finally, based on the using calculator, you can know what is the V2. Samalah, nasi dapat V2 15. Okay, so now you can understand on the correlations. Semakin kecil diameter, semakin what happened to velocity? Can you compare on this? Semakin kecil cross-section area. Anyone? Can you conclude this one? What is the correlation between flow rate, diameter and also velocity? Anyone? Dengar tak? Dengar tak
Makin tinggi velocity.
Bandai. Tadi 15 kat sini. So you boleh check back your calculation. Semakin tinggi diameter, semakin rendah velocity. Okay. Okay, let's see on another examples. So you have water flow through a pipeline. So pipe ni, pipe A mengecil jadi pipe B, kemudian split into two. Okay. So you need to make equation. So you have QA. QA mengecil menjadi QB. So this is Q in and Q out for the first time. And then they split into two. So you have QC plus QD. Okay, and basically kita akan solve part yang dah ada all information. So you can know QA dah boleh tahu. And also QB, sebab QA sama dengan QB, so sama je. And you can calculate the QD. Sebab QD dah ada diameter and also velocity. Okay. Lastly, kita solve velocity at point B and also velocity at point C. Okay. So this one they calculate the QA dapat 0.392. So QA ni sama je dengan QB. Okay, that's why when we find the VB, kita guna Q dia adalah 0.392. So dapatlah velocity at point B. Okay, kemudian kita kena calculate QC because we already know the QD. QD dah tahu. So we need to find the QC. QC adalah QA tolak dengan QB atau QD. QB ni QA tolak QA atau QB tolak dengan QD. Dapatlah QC. Okay, after we know the QC, then only we can calculate the velocity at point C. Okay, tadi soalan dia, condition dia out yang splitting. So this one, the in pipe is yang ada banyak cabang. Okay, because this is in, this is out. Okay, step dia sama. You need to make equation. So this one is Q3 plus Q2 plus Q1 equals to Q4. Okay, and then this question dia ada bagi different condition. Dia cakap bila flow rate, bila Q3 increase 30%, Q4 akan increase 15%. Okay, so this one you need to consider in the solving problems. So here 30% Q3, sebab Q3 akan meningkat 30% kan. Bila 30% daripada Q3 increase, 50% daripada Q4 increase. So that's why we have this equation. So kita simplify 0.3 equals to 0.15 adalah 15%. And you can know the Q3 punya flow rate. Okay, the Q2 can be calculated using the area and velocity. So we already know the Q2. Now we need to find the Q1. Okay, kita nak completekan this equation. Q2 dah tahu, Q3 dah tahu, so you need to find the Q1. Here Q4 also can be calculated because the information is already given here. Q4 adalah 200 liter per second. So the standard unit is meter cube per second. So we converting liter to meter cube, it is 0.2. 0.2 meter cube per second. So you can know the Q1. Tolak lah. 0.039 tambah 0.1 tolak 0.2. Dapat Q1. Okay, and then finally you can calculate the velocity of the Q1. 11.136. Okay. So, okay tak untuk continuity equation ni? Ada soalan tak? Waalaikumsalam. Okay, boleh tanya? Okay. Okay, pressure is different thing lah. So bila pressure ni, dia melibatkan elevation. Nanti lepas ni you akan belajar pressure, kita guna bernuli. Next topic ni. Kalau pressure, dia berkaitan dengan elevation. Kalau ada berbeza ketinggian, baru ada berbeza pressure. Okay, dia involve velocity dengan sama juga velocity dan juga ketinggian lah. Nanti lepas ni kita akan belajar pressure tu untuk pressure in pipe ni, dia ada pressure energy, potential energy, and also kinetic energy. Kalau dah tanya, saya bagi tahu je lah sikit kan. So dekat kinetic energy ni dia ada effects and velocity yang tadi tadi. Untuk potential energy ni ada melibatkan elevation. Then only you have the different pressure of the fluid ni. For the time being, you just calculate the continuity equation sahaja untuk topik ni. So untuk continuity equation which is related to flow rate ni ada soalan tak? Discharge. Untuk soalan berkaitan dengan pipe macam ni, dia tak ada melibatkan different pressure. Sebab this one is the pipe from the horizontal plane. If you still remember, kita ada vertical punya plane ataupun horizontal. So bila you tengok kat sini, you nampak macam ada elevations kan? 1, 2, 3 nampak macam different ketinggian. But actually there is no elevation. Okay, this part is the view from the horizontal. So bila view daripada atas tu sebenarnya tak ada elevation, pipe tu sama level. Boleh Boleh tak untuk velocity, untuk discharge ni? Okey ke? Tanya soalan tadi? Okay, if tak ada soalan, let's try a few questions from the tutorial. Let's try together so we can learn from that. Saya share soalan tutorial. For this topic, you can refer to tutorial 5, which is on continuity, energy, and also applications. Application ni melibatkan measurement using instrument, using device. So untuk device ni you akan belajar pitot tube, meter, orifice, later. Okay, let's try this one together. You have your calculator with you kan? So try soalan 1 ni. What is the discharge flow rate of the pipe? Q1 equals to Q2. Boleh calculate now. This is Q1 over Q2. What is the flow rate ataupun discharge of the pipe on the section 1? Section 1 dia dah bagi 10 cm, 5 meter per second. Boleh? Putri ada?
Ada doktor.
Dapat tak Putri? Macam nak kira Q ni?
Buat PAV1 equal to PAV2.
So berapa Q? Pi Q1 ni boleh kira lah. Pi D adalah 0.1 tukar kepada meter bahagi 4 darab dengan 5. Berapa Q1? Berapa Q1? Dapat tak? Dapat ke?
Dapat 0.039.
0.039 Okay, so now you can calculate the V, velocity at section 2. So 0.039 pi, D dia adalah 15. Darab dengan V2. So what is the V2? Apa V2 dia koyum? Koyum ada?
Give me a second. Kejap ya, saya kira kejap.
Okay.
V2 dia dapat 2.17.
Kalian dapat sama tak? Kalian dapat sama tak? Lebih kurang lah kot, 2.2 kat jawapan ni.
Saya dapat 2.2.
Lebih kurang lah. Nanti kira balik koyum kau dapat 2.2 ni.
Baik,
Ya,
doktor.
lebih kurang lah. Okay. Okay, so now try question number 2. So, bila tengok soalan ni pun, dah boleh tengok dah mana yang nak kena solve. Kita tak tahu V3. Okay, so kena carilah V3. And also the discharge. Find the Q and also V3. Boleh calculate dulu? Untuk question 2. Maybe Amin Nasrullah ada? Amin ada? Ada tak Amin ni? Amin? Ada tak Amin? Siapa sebilik dengan Amin ni? Ataupun Syed Irfan, ada?
Sekejap. Tengah check.
Okay, Syed share jawapan dekat grup. Kita discuss jawapan awak. Share jawapan dekat grup
Boleh.
Okay, saya tunggu. Boleh ke? Syed Irfan? Atau apa tadi ya? Amin. Dah share dah? Tak ada lagi ni jawapan dia. Boleh ke? Senang je ni. Boleh tak lah? Okay.
Saya dapat 0.57.
Boleh share jawapan tak? So kita boleh discuss. Saya tak tulis lah. You boleh tulis jawapan. Boleh share kat WhatsApp. Saya share kat Webex saya. Anyone lah. Selain daripada site mana? Site ke Amin. Tak dapat lagi jawapan ni. Okay. Irfan dah share. Thank you Irfan. So saya share kat sini ya. So we can go through together. Okay. So Q equals to AV. Can you see the question ni? Nampak kan?
Nampak doktor.
Okay. So Q equals to AV. Q1 equals to Q2 plus Q3. So dia masukkan pi 0.3 tukar kepada, dia dah bagi dalam meter ke tadi? Tukar kepada meter 0.3 darab dengan 2.5. So don't forget the unit, meter cube per second. So untuk ni syndicated marking So tak tentulah, mungkin ada lecturer yang strict on this. Dia akan tolak markah half ke kat sini. So elakkanlah untuk berkurang markah sebab you dah kira betul kan. Don't forget the unit. Especially the unit for the final answer. Ni answer lah sebab dia tanya di Q kan. Yang kat dalam-dalam ni tak payah unit pun tak apa. So the final answer must be incomplete unit. Okay, and then your friend calculate the V. Kita dah dapat Q 0.18. So Q2 plus Q3. Tengok balik soalan. You have Q2 diameter dia 2 dengan 20. Ni kenapa 0.3 ni? Q 2 dengan 20 kan? Betul tak?
Betul.
Ni 0.3 dapat kat mana ni? Ni 0.15. Betul tak ke saya salah? Anyway.
Ifan dia tersalah tulis.
Oh, dia salah tulis. Okay, tapi dia kira betul ya dapat jawapan?
Melirik.
Betul tak jawapan you all yang lain ni? Dapat 0.57?
Saya dapat 6.45.
Okay, so 9.45. Orang lain?
Kalau 6.333 daripada awal ambil 3 tempat puluhan.
Boleh lah. Ni decimal tak kisah. Yang penting you boleh buat betul calculation ni. So jawapan dia 6 pun saya dah tengok. Okay, 6. Betul lah tu. Okay, decimal we don't consider sangat kecuali yang macam ni. Ni saya cakap mana dapat 0.3, 0.3 kenapa 0.3 semua. Ni memang susah nak bagi markah ni. Tiba-tiba jawapan dia betul. Mungkin dia tanya kawan sebelah. This one tak dapat markah lah. Kat sini pun macam you suspicious kan? 0.3. Okay. So, the final answer is not important sangat. Yang penting you know the concept and know how to solve this problem. Debat jawapan ni satu markah je. Yang penting the steps ni, how you plan to solve problem related to discharge of the flow stream in the pipe. Okay, so you have another 45 minutes. No. 30 minutes kot sebelum pukul 12 ni. So you can try another question So boleh try soalan 3, soalan 4, soalan 5. Okay, soalan 6 ni tak boleh buat lagi sebab ini adalah soalan pressure yang macam kawan awak tanya tadi. So ni kita akan belajar next topic. So pressure, lepas tu ada heat loss. Okay, 6 ni tak payah buat lagi. Okay, you can try on your own. So kalau you rasa nak share dengan kawan how you calculate and we can discuss in the group, you boleh send kat group. So saya akan comment on the step to solve the problems tu. Okay, boleh ya? Boleh jawab 3, 4, 5 and share to the group if you want to discuss on that lah. Kalau nak jawab sendiri-sendiri pun okay je. Okay, thank you. Ada soalan? Okay, tak ada. Thank you. Please jaga diri. Sebab kita ada quiz next week. So you need to be prepared lah. Janganlah. Jagalah SOP, jarak. Jangan ada yang positif. Okay, be prepared for your quiz later. Okay, thank you. Bye. Assalamualaikum.
Salam, doktor.
Thank you,
Okay.
doktor.
Waalaikumsalam. Thank you,
Thank
doktor.
you.
Thank you, doktor.
Thank you, doktor.
Thank you, doktor.
Okay.